a stranger in your company and you met an electrical or electronics engineer, so you might want to greet him or ask him, hey, how's your circuits before? Okay, so why is it a lingo? Because this is the initial phase, no, of their major subjects. No, this is the first subject. Okay, so circuits one. So you can call me, yeah, you can call me Sir Ed, Engineer Piedad, or you can even call me by my first name. It's only in the Philippines that you call someone with Sir, no, or yeah. But you can call me just Eduardo or Ed, but I think it's a bit, no, you can call me Sir Ed if that's the case, no. Okay, so let's try to describe first the course. So Circuits 1 studies the basic principles of modern physics to apply and solve engineering challenges. Okay, so engineering challenges. Now, why I highlighted modern physics? Because this is the denominator, maybe this is the difference between as you can see, civil engineering, for example, so they build structure. So the other one, we call it the classical physics, no? In the 17th century to 19th century, so the most common physics is what we call the classical physics, no? So classical physics studies the buildings, I mean the structures, no? So for example, in your mechanics, no, you have a beam, okay, and it's supported, and then at point A, at point B, no, you need to you take the summation of forces along A, and then if it is in equilibrium, okay, if there's no motion, then you equate this one into zero. So if it is in motion, so you multiply by mass and acceleration, okay. So yeah, that's the idea of the mechanics. And although some physics, no, in our physics, so if you have billiard balls and if this ball running in this, rolling in this direction, and then this ball hits that billiard ball, and then they have a resultant. If they are perfectly inelastic, so they will come together. If they are perfectly elastic, so they will bounce back, no? Okay. So yeah, that's a principle of classical. So this is based on the Newtonian principles. So that we call this one the first law, second law of Newton, no? Or first law, second law of motion, for example. Okay, now that's classical. Now, so the application of classical physics, we all know navigation. Shipbuilding, and also we have buildings, no, structures, bridges. So those are the common things, no, and also partly mechanical, no. During the initial phase of industrial revolution, no. So we have discovered some tools, okay, for mechanical. So for example, the wheels in the no, so you have the water, no, yeah. So to irrigate the land, no, the field, so you have the wheels, for example, okay. And then but in the later part of the industrial revolution in the 20th century, so we discovered the modern physics, no. It was initiated, or we can say that Albert Einstein started the modern physics, no, because modern physics talks about okay, so the start of this is during the time when the photoelectric effect by Albert Einstein was discovered, no. This in the earlier part of the 20th century, or if I'm not mistaken, the last years of 18th century, or sorry, 19th century. And yeah, so the discovery of photoelectric effect, and also the discovery of electrons, no, the Maxwell effect, etc. So the application of modern physics, so very simple. The application of modern physics happened, really come into realization during the World War II. Okay, World War II, because during the World War II, we discovered radar, no? Radar. So if radar was not discovered, probably the allies, no, the U.S. and the England would have been I mean we the allies would have been lost, no, without the radar, because of the Germans uh, superpower, no, in the U-boats, no, or the submarines. And also we have used radios. Now another term for radar, sonar, and these are different technologies, no, communication with different frequency radios, okay, and etc. And also we have learned about the atomic bomb, no, although it's not the desirable application, but it so happened that that's part of the modern physics. Now, um, there are many other applications, no, of modern physics, and we can summarize that one with the term electricity. Okay, so during the time of Thomas Edison and Nikola Tesla, so we realized the importance of modern physics. Okay, so that's why the light, illumination, and we have. Sorry, I'll try to um, approve these guys who are coming. Okay, so that's it. So yeah, so due to we have so we have the modern physics, and we study this one because it's already part of our daily lives. We are using electricity in our homes, in our offices, in our companies, and yeah, so specialized. So that's why EE comes into play, no? EE, electrical engineers. So deals with the EEs deal with the electricity, and then because of the advancement during the World War II and the funding from the U.S. government and from the other countries like the Europe and England, no. So okay, so the research and innovation comes into play, no? So that's why it becomes so advanced that it comes to a field of ECE, no, the electronics, when the parts of the device of sorry, when the devices, no, become really small, no, due to the advancement in material science, no, materials engineer, uh, materials. Material science and engineering. So actually, because of them, so we were able to minimize the physical structure of the um, circuits. And then because of the advancement in computers, no, and then development of programs, then we have the computer engineering. Okay, so I'm not saying that E is the no, um, is the superior field. But what I'm saying here is that we share the same principles. Okay, so that's the circuits. Okay, for EE, ECE, ME, and CPE. So our common denominator is circuit. So I'm not saying that E is superior, but actually we can help each other especially in the company, and it's only in the Philippines that if you're EE and then you just focus on this field and this, actually you can go to the other field, no? So if you notice, successful people, they change careers 3 times, no? I mean, on average, 3 times. So there are those famous guys who have PhD and but ended up in a company, become an executive, no? So they or become a famous writer or a famous comedian like if you heard about Mr. Bean. Now, Mr. Bean has a master's in electrical engineering, and yeah, he shifted career in probably that's what makes him happy, no? And we all want to be happy in this case. So we again going back to the subject. Now, some of you are mechanical engineers, some of you are industrial engineer. Now, why is it you need to study this course? And because this is a common denominator, not only for the EECE and ComEng or material science engineer, but also for all engineering disciplines. Because as I said earlier, we are using these circuits or electricity in our daily lives, no? And we are the sorry, and we are the frontliners, no, in the innovation and technology. Okay, so that's why we need to know a bit of other disciplines. So if you are an industrial engineer, you may need to know, okay, so what are the safety for electrical equipments, and so that you can create an ergonomics, no, or a efficient material handling or equipment handling, or you can also deal with okay, when you become a manager, you can also try to ano, no, understand your colleagues, electrical engineers or electronics, etc. So yeah, there also for mechanical, so they also need to understand the basic of electrical, like because most of the devices or equipments or motors, no, they are electric powered, no. So seldom you will encounter equipments that are simple enough, no, that doesn't need electricity. So okay, so I'm not saying again, no, that is superior, but what I mean is we have the common denominator here, and that's electricity, and we all need to be acquainted with it, no. So this is circuits one, and there's circuits two, and so circuits two. So the other guys here, EEC and Coming, will study this subject. But in the circuits one, we will just focus more on the basic principles of modern physics to solve and apply, or sorry, to apply and solve engineering challenges. Okay, sorry, just a moment. I'll just admit the. Okay, so this covers the different DC circuit analysis tools and network theorems, fundamentals of capacitors and inductors, analysis of DC-driven RLRC and RLC circuits, and also an introduction to AC systems, or alternating systems. So, as I said, in the circuits too, we will focus more on the AC systems. So, for those, so EEEC and CP. So, so this course, I hope you will find it um, interesting, and also, I would say, uh, help in your future career, no? Whatever field you are. So it also presents and orients students about the advanced and emerging technologies. So later in this course, we have allocated time or allocated class hours for the recent innovations. For example, the if you have heard about space, um, SpaceX, also the Boring Company of Elon Musk, and also the race to space, or sorry, the race to Mars, where Elon Musk also become part of it, and biotechnologies. So there are many recent innovations, and artificial intelligence. So what makes why is it circuits are part of it? Later we will know that because of the network theorems. Okay, so well, uh, it's so early to tell you. Okay, so but we will allocate time for these emerging technologies so that you will be aware, no? Because it is necessary for example, if you're thinking outside the box, no, and but you don't know what is a box. Okay, what is the boundary of our present scientific knowledge? Now, if we are limited with our scientific knowledge, the box that we are thinking is still inside the box of another bigger box, no. So we cannot innovate because whatever we innovate uh, outside the box, the limited box, may be or may have been discovered already, no, by some other guys. Okay, so that's why we need to learn other technologies. Okay, this is an introductory course common to all engineering students, and the first major subject of EE is EE majors, and also I think ComEng. So if I'm not mistaken, with their new curriculum. So okay, this is also known as fundamentals of electric circuits, circuits one or electric circuits one, and basic electrical engineering. So there are different names because different departments or programs of our college have different syllabus, no? So they name according to their taste, no? But we are trying to make it a uniform name in the future syllabus, no? So, but don't worry, you are enrolling in this course, so that means you are allowed to take this course. Okay. Otherwise, if you're not part of this class or this course, you may. It's okay for me to attend the class. Just let me know if you are outsider. No? So okay. So now we go to the course outcomes. No. So enabling means the level 2 difficulty, and there are three levels: the demonstrative, enabling, and introductory. So introductory is the level 1. Okay, so we need to apply in this course knowledge of mathematics and science to solve complex engineering problems. So in this course is also an introductory to provide foundational understanding of the program outcome. So yeah, so if you are ME, IE, EE, ECE, so you need if this course will give you some foundational or basic knowledge, no, or understanding to whatever your program is. And also it is also introductory to use techniques, skills, and modern engineering tools necessary for engineering practice. For example, the devices, electrical units, or whatever. Yeah, all of these. Okay, and lastly, we will try to incorporate or integrate in our class communication, no? Because in the industry, the first important skill we need to learn is communication. Okay, in my part, I'm also learning that way, no, the hard way. We are not natural speakers. Some of us are natural speakers, so we need to nurture. We need to learn more, no. And for us guys who are average, no, or even worse, no, we cannot speak English fluently or pronounce well, so we need to practice, no. So that's why I encourage you to, communicate in English medium. No, our university is encouraging, or it is part of the no system, no, to use English as the medium of instruction. Okay, so well, in part of the class, okay, so part of the output will be this communication. Okay, so we'll talk about it later. Now let's proceed with the course intended learning outcomes. First, the first silo. So we would like to apply laws and theorems of physics to solve the direct current and basic alternating current circuits or systems. Okay. Then second, we need to identify, measure, and analyze variables and parameters of an electric circuit and its related systems. Okay, so we can analyze a circuit in that way. Okay, and now the third silo depends on the lecture. So this class is a lecture, and we have a laboratory class for those who are taking EE to A2. Okay, so I'm the teacher for the Friday class. So yeah, so this is the third silo for the lecture and the lab. Okay, so assess and evaluate advanced electric circuit and its emerging applications. Okay, so so what are the advanced electric circuits? So we don't need to solve no some problems probably, no. So we need to be oriented with advanced electric circuit, no, and then also the emerging applications. For the laboratory, so we need to validate basic electric circuit concepts through simulation and or experimentation. Now, because of this pandemic, so we are limited with simulation. Okay, but it's also part of experimentation. Experimentation doesn't mean manual experiment. No, experimentation is a scientific approach of validating theoretical concepts. Okay, so that's it. No, so we have three silos for lecture and then three silos for laboratory. Okay, so for the syllabus, so by the way, if you want to ask questions, so please feel free to interrupt me. So if there's no problem in this time of orientation. So, or if you don't want to be heard, you can just write in the chat box. No, so in the right portion of your screen, or if you're using a smartphone, then. Try to see if you can write something. Okay, so I think I heard some message. Okay, so some concern. Sir, good morning. Concern sir sa akong LMS kay wala ni appear A2A1 na course pero nasa uban classmate ako. So, okay, so maybe I remember enrolling you in the class. Probably I mistook the other email ad that you're using. So I will check again after the class, okay? So don't worry about it. And thank you for finding way to enter the class no, with your classmates. So, okay, that's a good discarding moves. No, that's a good thing, no? So we help each other so that in this time of pandemic, so I encourage you guys to communicate with each other in a just way, no? So I mean, you can help each other to teach each other, and okay. So, but during the no quiz and exam, so I hope um, you help in a way that is not against the. I mean, we have a rule, but um, against your conscience in that sense, no. But if you don't have a conscience, you're not a human being. Anyway, so okay, so just interrupt me if you have questions. And okay, so syllabus, okay, the course syllabus. So we have today we have the class introduction, and then we have 7 topics for the prelim exam. And this is based on a textbook, so I will introduce the textbook later. And some parts are not part of the textbook. Now we are a bit delayed already, so we're supposed to start last August 13. Oh, sorry, August. I don't know, 2 weeks ago, last week. Okay. So what I remember is we are delayed by 5 hours. So probably we should have we're supposed to be in this part already, but because of the activities that we had and some technical difficulties in the management, so we will try our best to deliver these content. So what really matters here are the essentials, no, the concepts and principles that you will be using in your respective field. Okay, so what I'm going to do in these 3 topics is I will upload it in the learning management system. For this one is on Friday. Sorry, this is today. I will upload it today, and then this is on Friday tomorrow, and then this is on Saturday. So it will not take too long, maybe 20 to 30 minutes, and I will upload it in maybe in YouTube, or I don't know. Let's see if where can we upload it, no? And so you can access it asynchronously, no? So you don't need to be online at a certain time of the day. Watch the videos any time of the day. But I also encourage you to read the book, no? Because the lecture will just give you the specifics or the highlight of the textbook. So after the lecture, I encourage you to read the book, no? So the book will not take you too long. No? It will just one topic will take you maybe 10 to 20 minutes. So it's good, no? In that day, watch a video for 30 minutes, and then read the book for 20 minutes. You have 50 minutes for this class. It's not a problem, no? I might start the class for this today. No, I think we have ample time, so it's still at 8, and I think we can start that one, no, for the fundamental physics. If we can end early and we can start the first lecture, okay. So I think it will not be a problem to you guys, unless if you would like to say, sir, I haven't taken my breakfast, so I need to take my breakfast. Yeah, that's right. I will consider that one. Maybe a short break na lang, 15 minutes before we start the first lecture. But I would like to finish it, this orientation in a while. No? And then in the second part of this prelim, so we will talk more on the the first part is focused on the review of the basic principles you've learned already. I mean, especially the physics, no? You've learned already in your previous class. And for the second part, so we are going to introduce the circuits. Okay, so the DC direct current circuit. And part of the prelim is the one basic application. I mean, it's not. I might say not really part of it of either of the two parts, but this will help us. Okay, so this is a practical class, no, understanding your electric bill. So when can you say that you are saving, or how can you save, etc. Now, what are the parts of your electric bill, so on and so forth. Okay, so how to understand your electric bill. So it's not so long. No? Okay. Then we have our prelim exam. Okay, so for the midterm, we have cells, batteries, magnetism, and alternating current basics. So cells and batteries are basics, no? We are using our devices, so for sure you're using batteries, no? When can you save your batteries? How do you save your batteries? How to connect your batteries? For example, if you have a some devices that needs battery cells, no? So how to connect them? And then also we will introduce magnetism. Although this magnetism is very deep, no? So but we will just discuss a little bit, no? Because this is one entire course in electrical engineering. We call it the electromagnetic. So it takes one whole semester, no, to really understand magnetism. But I know you guys are very good. I suppose you can understand magnetism. I mean, you are experiencing magnetism. I mean, you are using things with magnets, no. So I suppose you will understand easily, no, the concepts. And then now we're going to introduce the AC basics. Okay. And then we will proceed to these parts. No, these are essential also. No, these are the seasons. No, this what makes the circuit difficult, but at the same time useful. No, in that, for example, the inductor or inductance. Inductance is the I mean the principle in the inductor. Inductor is the device. Then capacitor, capacitance, phase, and then the reactance. No, so all of these are makes a circuit difficult. But okay, so things that really difficult, there's always a positive. No, that's there's always a good that comes out from difficulties or suffering, for example. No, so yeah. And then we'll have quiz and then midterm exam. Okay, so I just put 2 hours because exam week is will cover actually we 3 hours in our class. We are 3 hours anyway, so we will adjust, no, what in our respective time. Okay, so and then for the finals, we will talk about impedance and admittance. Okay, so these are actually resistance, but they are different names because now they involve the resistance. No? And then we will talk about AC circuit analysis. You will find out that this is the same with the DC analysis. And then we'll talk about a bit more on the power and resonance. No, what's the difference between power and volt amps? No, volt amps is also a power. If you notice in a motor, electric motor. So there's a volt amps or kilovolt amps. Now, what's the difference between the power? Okay, 1 horsepower, for example. Okay. Okay, so then I'm not sure if we're going to talk about this one, transformer and impedance matching. If we still have time, then we can talk more transformers and impedance. But for those who are taking circuits too, don't worry, you will be we will be discussing this one in circuits too, given that I will be your instructor. But for sure, the instructor in the circuits too will talk about more on transformers and impedance matching. Okay, and then lastly, we'll talk about the latest emerging devices and systems. And we have our final exam. Okay, so this is the class schedules. So okay, so if you have questions, no, just let me know. Okay, so we are a bit delayed by 5 hours, so this is 7 hours, and yeah, so we are already in the 27th. So we only have roughly 2 weeks, no, or maybe less than 2 weeks. So that's why we have changed the schedule and also the means of lecture. So I will give you a asynchronous lecture, no. So I will just upload the videos for the 3 topics. The 3 topics doesn't it's not really that difficult, no. So even if you just simply read the book and you already get the idea, no. But if you want to be more, the more you encounter the concept, the more you understand them. And then, so yeah. Um, so now we have deliverables, no, for those who are taking EE to A2. So we will have a case study, no. So I will further explain this one in our EE to A2 class. Okay, and then so for the sake of to impart communication, so I would like you to uh, prepare a presentation in a video form. Okay, so based on your case study. So I will further explain this one later. Okay, uh, later in our class. And then for other programs other than those who are not taking AE to A2, so what I would like you to do later in the end, I will introduce this one in some after prelim, the emerging devices and systems. Okay, you just simply create a term paper, maybe it's like a research paper. Just go deep, do some small basic research, no, on what are the latest development in this area, no, so something like that. Then you need to present, no. Okay, so I will show you some videos later when I introduce this deliverable. So the previous batches that creates these that they shared their ideas, no, videos. uh, okay, so the grading for this class is 25% for each assessment, especially the deliverables. And every topic, so in the prelim, we have 7 topics. So 7 topics, they have each has respective homeworks. Okay, so the homeworks helps you understand the concepts, no? So or to review the concepts. So it's not so big, the 5%, no, but the purpose of the homework is for you to assess yourself whether you understand the concepts. Okay, now for the quiz, so we have 2 quizzes in prelim. I think each of the term, no, prelim, midterm, and finals. So basically 5% each. And then for your exam, so you have 10%. Okay, and for this is for the 3. And for the deliverables, I will be posting it later because it will be dependent on the, maybe there will be changes in the schedule. Maybe we will extend our class days. So okay, so it will depend on that. Okay, now you have any other concern or questions? Okay, so maybe you will ask me, sir, do we need to meet every now and then, like Tuesday and Thursday, 7:30 to 9. I would say not always, no? Or it depends. For now, we are struggling with, we're catching up with the delays. So we are going to meet next Tuesday, um, and then also Thursday next week, no? Because we are catching up. But there are times if we are already on the right time, maybe we will do it asynchronously, no? So, for example, Tuesday we'll have a lecture, and then you can do your homework in the on the Thursday, or your projects, okay? Or and then I will just post synchronously the lecture, and for you to have more time, no? So that also, this is also good because some guys can, for example, today some guys are late, probably because of their internet connection. So the asynchronous method of teaching also helps, no? And then in the class, we just simply review them, no? For example, today, sorry, this week, Thursday, Friday, Saturday, I will upload each lecture videos, and then on Tuesday we're going to review them, and then on Thursday we're going to have our quiz. Okay, we have our quiz on Thursday, so we'll have to review first on Tuesday, and then I will check. We will check our homeworks. Okay, so each of the videos, I mean the topic 1, 2, and 3, they all have respective homeworks, and then the homeworks will just, I mean, before this, the deadline of the homework will be before that, the next class, no? So that would be before Tuesday, before our class. So I will close the upload before the class, no? Okay. So I hope it's clear. And if you have other questions, so if it's not clear to you, I think I will post again in the group announcement. Okay, so in the announcement portion. Okay, so and then textbook. So I don't want you to be deprived of an ebook. So you can go to this website. So I'm using this textbook because it's really simple to understand, especially some of us are very limited English. So and then also the good thing with this book is the content structure is very user friendly. Okay, and also we have access. Okay, so um, you can use this access and to enter this link, no? I think I posted it in the LMS. If not, I will upload it today. And yeah, you can go inside, and then, but so as I said, most of the contents of this class can be found in the textbook, but some of it are not, no? These are some of the references, but this is subject to change, no? Because I'm adjusting my lectures dependent on the previous lecture. So maybe based on your feedbacks or comments, so I might adjust them. Okay. Then the policy. So absent. So that's why if you look at your LMS, you can check your own attendance, no, during the class hours. So I will not record late, because I understand that each one of us have difficulties, no, in internet access. But you know for sure that if you're late, no, you're late, no, and it's up to you, no. It's good to practice punctuality because punctuality, it will become part of you, no? It will become a virtue, and then when you work in a company, you don't need to worry about punctuality because it's embedded in your subconscious, no, in your subconscious mind, no? And then okay, so If you cannot, okay, of course, if there's some problems, just like what happened yesterday with other class. So some students were not able to access the internet because of some power interruption yesterday. So yeah, they messaged me through text or email, then no problem for me. Okay, so okay, so I think it's not a big deal. Now you can contact me through this email, and then please introduce yourself and what class are you in, and then also please respect the privacy for my info. Please don't share it to your other than the class, no. And also don't text me that sir, please help me, I'm on an accident or mga scam. Okay, so or maybe you want to sell something. So please don't do that. Okay, so and also email here, so you can do that this way, so it will be organized in my email. And I hope not there's no problem on this. So okay, so is there any question? Would you like to now also you can like the department, no, electrical engineering department. So we are posting some webinars. We invite professionals to discuss and to give ideas, no, of the emerging technologies. Okay, um, and also to help, you know, to our department, also our college. So you have any questions for this class? Okay, so there's a concern here in the chat box. Sir, good morning. Sir, nako'y concern if na-dissolve ang circuit select na Tuesday 9 a.m. to 12. Okay, so this is lecture or lab? So I suppose this is lab. And if you are, I forgot the offer code for the lab, 9 to 12. I suppose that should be like laboratory, no, circuits lab, 9 to 12. And there are two sections there. I suppose you need to enter. Sorry, no lab. I mean, okay. So you need to take the 4111, if I'm not mistaken. Let me check for the lab. Um, sorry. So please feel free to ask questions. Okay. I think you need to enroll in 4112. Okay, lab 4112. Okay, so instead of 4185. I think if I'm not mistaken, so some of the EE guys there already transferred to 4112. So I'm not sure. I'm not sure if I'm the one handling, but I'm handling the one on Friday. But I'm supposed it's already full, and we're still deliberating who can deliver the other class. Okay. Okay. So there's no one so far. What is no one so far? Okay. Any question, guys? Okay, so I suppose there's no question. So we can start the first lecture at 8:30. Okay, 8:30. So kung wala na may question, 8:30. So we'll take a break, short break, around 9 minutes. And after that, we'll start the first lecture. So we still have time, and we would like to utilize all the means possible. Okay. So see you in a while, and I will not turn off this presentation, this Google Meet. Okay. So you may leave and come back later, or you can just simply, okay.